We're thrilled to welcome you to the newly added Generative AI module for the AI-900 course, featuring content updated in May 2025. Generative AI is a type of artificial intelligence that creates new, original content. Instead of just analyzing existing information, it can produce things like text, such as a poem or a story. Images, like a purple cat playing a guitar. Videos and code. How does generative AI work? Generative AI models learn intricate patterns from massive datasets and use this knowledge to understand a user's prompt, generating new, original content based on the instructions. This capability is largely enabled by advancements in natural language processing, NLP, leading to the creation of large language models, LLMs, like GPT-4, which are defined by their immense scale and training data. The generative AI landscape is also expanding with highly efficient smaller language models, SLMs. These more compact and resource-friendly versions of LLMs are practical for specialized, fine-tuned tasks. Their reduced requirements allow for high-performance deployment on edge devices like smartphones, moving generative AI capabilities closer to the user. Together, both LLMs and SLMs drive the creative shift in AI, moving it beyond simple analysis to active content creation. Understanding the fundamentals of NLP is crucial to grasping how these models process and generate human-like text. So let's recap. Tokenization is the process of breaking down a sequence of text into smaller, meaningful units called tokens. This allows machines to convert human language into a numerical format they can understand and process, serving as the first crucial step in natural language processing. Word embeddings are numerical representations of words that capture their semantic meaning and relationships. By mapping words to vectors in a high-dimensional space, they allow machines to understand context and identify similarities between words. A transformer model is like a translator that works in two steps. Let's first look at how the encoder works. The encoder, understanding. This part reads your input, the prompt, and tries to understand the full meaning. It turns the words into a special code called embeddings. The key is attention, which is like highlighting the most important words and seeing how they connect to each other. The transformer model reads the sentence. When it processes the word guitar, its attention mechanism would highlight playing. It immediately sees that guitar is directly related to the action of playing. Notice cat. It understands that it's the cat that is doing the playing of the guitar. Connect purple to cat. It knows that purple describes the cat, not the guitar or playing. So instead of treating each word in isolation, attention makes the model aware of how all the words relate to each other. The decoder, generating, this part takes that understanding code and starts writing the response. It predicts the next best word, one word at a time, based on everything it understood from the encoder and all the words it has generated so far. It keeps going until the sentence or story is complete. The power of prompts. We've discussed how LLMs and SLMs work, but how do we actually talk to them? It all comes down to the prompt. There are two main types of prompts that structure the interaction. System prompts. These set the overall behavior, tone, and any constraints the model must adhere to. Think of it as the model's job description. For example, you're a helpful assistant that responds in a cheerful, friendly manner. This is often hidden from the user. User prompts. Specific questions or instructions that elicit a response. Conversation history. Generative AI tracks conversation history to maintain context. A summary of this history is added to subsequent prompts, ensuring relevance. Retrieval Augmented Generation, RAG. To provide even more reliable and current context, generative AI applications use a technique called Retrieval Augmented Generation, RAG. This approach involves an initial step of retrieving external information, such as documents or emails, and then using that data to augment or add to the user's prompt. The model then generates a response that is grounded in the provided information. For example, when you ask, "What is the connection string for the primary production database?" a RAG system first queries your organization's IT configuration documents, retrieves the relevant string, and includes that data in the prompt so the model can provide a precise, factual answer instead of a generic one. AI agents. Agents are software applications built on top of generative AI, designed to be smarter than a simple chatbot because they can reason, plan, and act. Every effective AI agent has three core elements. First, the large language model, LLM, which is the agent's brain. It uses generative AI for all the language understanding and complex reasoning. It's what allows the agent to decide what task is required. Second, the instructions, which act as the job description. This is a system prompt that defines the agent's specific role and behavioral rules. Finally, the tools, which are the agent's hands and resources. These allow the agent to interact with the world by either retrieving information from databases, knowledge tools, or performing real-world tasks like sending emails or updating calendars, action tools. With these three capabilities, AI agents can intelligently automate complex tasks and collaborate with you to work smarter and more efficiently. Multi-agent systems. The true power of this technology comes when agents work together in multi-agent systems. This is where multiple specialized agents collaborate, much like a human team on a complex project. For example, one agent might gather data, another might analyze it, and a third might take action. They communicate using prompts, with generative AI intelligently determining the required steps and delegating the task to the right specialist agent. This development, known as agentic AI, is the next major advance in using technology to automate complex workflows. To recap, this module provided a comprehensive overview of generative AI, defining it as the creation of new content, text, images, code, using models like LLMs and efficient SLMs. It explained the foundation in natural language processing, NLP, covering key concepts like tokenization, word embeddings, and the transformer model's encoder, for understanding via attention, and decoder, for generating text. Interactions rely on prompts, distinguishing between the system's behavioral instructions and the user's specific query. The module then covered advanced techniques, Retrieval Augmented Generation, RAG, which makes responses more factual by augmenting the prompt with retrieved data, and AI agents, which use an LLM and tools to automate complex tasks, often collaborating in multi-agent systems to handle end-to-end workflows. Our next topic focuses on implementing generative AI solutions using Azure services.